to logs here. So the first thing we're going to take a look at is take a look at this first column, and we're going to see if you can see any patterns here. And let's see if I can get this Mobi to work here. Let's see. Hopefully this will work. But again, be looking at that first column and see if you see any patterns, what the pattern is between each one of these. And then we're going to talk about how that pattern transfers into what we call logs here. There we go. So sorry about the delay there. But hopefully you have noticed this pattern here. Oh, what a mess. Let's see if we can get this to go down. Come on. I don't know what's going on. Anyways, all right, here we go. So taking a look at this, some of you probably saw this pattern. 2 to the third equals 8. 2 to the fifth equals 32. 3 squared equals 9, and so on. So if you were to fill in the blanks, let's say this is x. We were to rewrite it 2 to the x equals 16. So we know that this one would have to be 4. 6 to something equals 36. So this one would equal 2. This would be 5 to the third, so we have 125. This would be 2 to the negative 1, so 1 over 2 to the first, or 1/2. And then in this column, we have to evaluate it. So 10 to something equals 1 over 1,000. Well, it's got a flip down here. So this is 10 to the third, so it has to be negative 3. Something squared equals 9, or 81, so that has to be 9, because 9 squared equals 81. Something to the fourth equals 81, so that would have to be 3. And this would be 16 to the power of 3 over 2. So again, we split that up to the 1/2 cubed. So 4 cubed is 64. So as we take a look at this next bit here, some general notes. A log is a power of an exponent. And so the way we read this is log base 2 of 5 equals 32. So this subscript is your base, and what it means is 2 to the fifth is equal to 32. So this one is log base 3 of 27 equals 3. And what this one means is 3 cubed equals 3. So if we had to evaluate this, it equals something. So 2 to the x equals 16. So this is equivalent of 4. So now we're going to switch back and forth between these forms here. Key thing to remember, base of your log is the same as your base of your exponent, or your power there, of your exponential part. So here's your base, here's your base. So in log form, well, what is our base is 3. So log, that's subscript of 3 of 81 equals 4. So again, it's saying 3 to the fourth equals 81. Our base here is 2, so log base 2 of b equals 5, because then we have 2 to the fifth equals 5. Write the following in exponential, so what's your base is 2. So 2 to the x equals 4. The next one, our base is 5. So 5, our exponent would be the 3, our power, equals x. So if we had to solve these, let's rewrite them in exponential. So 2 to the power of 6 equals x. So 2 times 2 is 4, times 2 is 8, 16, 32. So we got this one, x equals 64. And this next one, what's our base? Well, x squared equals 81, so x has to equal 9. So your assignment is that maze assignment. Hopefully you can navigate that. Let's see if I can bring it up. It's being kind of weird right here. I don't know what's going on. Can I shut this? Well, this is, I don't know if I can get into this folder that's hiding behind there. So it's that maze assignment, which I believe is page 4, where you'll be evaluating some of those logs.